Welcome back to Backer Breaks It Down. In this lesson, we're going to look at how we can use coordinates to classify quadrilaterals on the coordinate plane. So we're going to need our coordinate geometry formulas. And this table kind of nicely summarizes when we would use these formulas when we're working with quadrilaterals on the coordinate plane. So the distance formula, I can use the distance formula to determine whether sides are congruent or if diagonals are congruent. I can use the midpoint formula to determine, and I guess I would use it for, whether diagonals bisect each other. Because from the previous module, we saw the proof that if the two midpoints of the two diagonals are the same, that proves that they bisect each other. And then the slope formula, which you'll probably use the most, can be used to determine whether opposite sides are parallel, because parallel lines have the same slope, whether diagonals are perpendicular or sides are perpendicular, because perpendicular lines have slopes that are opposite reciprocals of one another. So if you are told to prove that a quadrilateral is a parallelogram, rectangle, rhombus, or square, here are some easy ways that you can do that. To prove that a quadrilateral is simply a parallelogram, you're simply going to prove that both pairs of opposite sides are parallel. So you're going to use your slope formula. Parallel lines have the same slope. For a rectangle, you must first prove it's a parallelogram, and then prove that two consecutive sides are perpendicular. So there's not really any additional work here if you've already proven that it's a parallelogram, because you've already done the work, you found all the slopes, so now it's just a matter of looking and seeing whether a pair of consecutive sides are perpendicular, so opposite reciprocal slopes. For a rhombus, I could prove that all four sides are congruent. I'd have to use the distance formula 4 times. Or I can first prove it's a parallelogram and then prove that the diagonals are perpendicular. So once again, it's just all about the slopes. And lastly, for square, I'd have to prove it's a rectangle and a rhombus to be a square. So in this example here, it says show that BOXY is a rectangle. So according to our table here, I have to first prove it's a parallelogram. And I'm going to do that by proving both pairs of opposite sides are parallel. Right? So this is my plan, but I got to start here with both pairs of opposite sides are parallel, and then I can show that two consecutive sides are perpendicular. So I have already done the work for parallelogram. I found the slope of side BY to be -2 and the slope of side OX to also be -2. So I proved that BY is parallel to OX because they had the same slope. And then I found the slopes of the other two sides. So the slope of BO was 1/2, the slope of YX was 1/2. Same slopes means they're parallel. In order to show that it's a rectangle, I need to show that consecutive sides are perpendicular. Well, if you look right here, BY and BO are consecutive sides. Let me identify those in the diagram. Here's BY and here's BO. So they are consecutive sides, and I want to prove that they are perpendicular. Well, in order for them to be perpendicular, I need slopes that are opposite reciprocals. And -2 and +1/2 are opposite reciprocals. So I know that BY is perpendicular to BO, which means that angle B is a right angle and makes this quadrilateral a parallelogram. Well, and more specifically, a rectangle. Speaking of rectangles, In this example, HILR is a rectangle. Granted, where is L? That is the question. What are the coordinates of the fourth vertex? So I can once again use the fact that consecutive sides are perpendicular. And it being a parallelogram, I know the opposite sides are parallel. So I can work with either one of these facts to find the missing vertex, right? So if I look at the slope of line HR, to go from H to R, I have to go down 4 and right 1. So what if I did the same thing from point I? What if I went down 4 and right 1? That gives me a fourth vertex at 6, -1. And that creates the rectangle that they asked me to do. So 2 more examples, okay? So here we're given the coordinates of A, B, C, and D, and they tell us that it is a parallelogram, and they want us to prove that it's a rhombus. Now, the fact that I already know that it's a parallelogram, that's a nice amount of work already done, because it says first prove it's a parallelogram, and then prove the diagonals are perpendicular. Now, if it helps, if you're like wondering where does it look like, I'm just going to draw parallelogram A, B, C, D, and I'm not even going to draw it in the coordinate plane because honestly, it doesn't matter for this purpose. So here's A, B, C, D. I just want you to see the general locations of the 4 vertices. Right. Now we want to prove that the diagonals are perpendicular. So I want to prove that AC I want to prove that that diagonal is perpendicular to BD. And I can do that using slopes. So I'm going to use my slope formula, and I'm going to find the slope of AC. So y2 minus y1 over x2 minus x1. So the slope of AC is 1. Now I'm going to find the slope of the other diagonal, BD. So y2 minus y1, x2 minus x1. So I get 4 over -4, which is -1. So I found the slopes of the 2 diagonals. And what do you know? 1 and -1 are opposite reciprocals, which means AC is perpendicular to BD, and if the diagonals are perpendicular, it's a rhombus. So they told us it was a parallelogram, and we used the slopes of the diagonals to prove it was a rhombus. So let's take a look at a similar exercise, but this time let's prove rectangle. So once again, I know that the parallelogram, MATH, like I know that to be true. So I know it's a parallelogram, and I want to prove that MATH is a rectangle. Well, according to this, first prove it's a parallelogram. Well, I know it is. Then prove 2 consecutive sides are perpendicular. So once again, if it helps you, you can just like draw regular, plain old parallelogram or quadrilateral, and you can, name the vertices just so you can see the relative positions. I need to pick 2 of these sides to show that they are perpendicular. So I'll go with side MA and side AT. And I'm going to find the slopes of those 2 sides. So let's start with the slope of side MA. So I have y2 minus y1, x2 minus x1, you get -5 over 3. for the slope of MA. The slope of AT, so y2 minus y1, x2 minus x1, it's 6 over 10, which simplifies to be 3/5. So I'm trying to prove that MATH is a rectangle. So I need to show two consecutive sides are perpendicular. Well, I just did that. Side MA has a slope of -5/3. Side AT has a slope of 3/5. Therefore, I have shown that MA is perpendicular to AT and that MATH is a rectangle. So that's how Backer breaks it down using coordinates to classify quadrilaterals on the coordinate plane. Have a nice day.